a project we're very proud of. We are working on this in Google Research, but in fact, it's not only a Google Research project. It's a project now that's being developed by many different people in Google. We are really working on this together to bring and connect technology with data and opportunities, if you'd like, to many people around the world. So I'm very excited to share it with all of you. I want to say that we only have an hour, and I have a lot to share. And therefore, I'm going to leave some time for questions afterwards, and I hope at least 10 minutes. But I also encourage you to stop me during my presentation. You can raise your hand, you can type your question in the chat, whatever feels comfortable for you, because I really want to address any pressing questions if you have any. I'm going to start by saying a few words about Google Research, because I think that not everyone knows about Google Research. So I really want to give you only in a few words a short introduction about who we are and what we are doing. And then I will dive just straight into the geospatial domain and Earth AI and everything we do in this area, hoping that it will be interesting for you to listen. Okay, so let's start. Let's begin. As I mentioned, I wanted to say a few words about Google Research before I begin, because I get this question a lot. People know Google, of course. People know that we are doing research, but there's more than one research lab in Google. Of course, there's DeepMind and Google Research, and sometimes people are not sure exactly what we are doing. And this confusion is actually not surprising, because there's a lot of overlap between DeepMind and Google Research, and in many cases we're doing things together in a collaborative way. But if I had to differentiate between those two different organizations and to focus more on Google Research and explain what we are doing, I would say that Google Research is focused on applied research. We are actually looking at how we can take technology and models and data and bring them into impact today in multiple domains. I will show you the specific topics, the specific subjects we are focusing on, but everything that connects science, technology, data with society, with science, with education, with energy, with health, everything that is pressing and interesting for all of us right now. DeepMind is a magnificent organization. This is the organization that is standing behind our Gemini model, and they're also doing many exciting things, including in the world of applied science, and these are the areas where we collaborate. And if you have additional questions about it later on, just let me know. I think that, you know, when I try to explain to people what are the key things that really are unique about Google Research, I say at least 2 or 3 things. One, we are not addressing small problems. In fact, in many cases, when the problem looks too small, too simple, too trivial, we many times prefer to skip and not to focus on it. So really, the most challenging, critical, strategic problems, these are the problems that we are trying to address using our talent and technology and the experience. And the second point I always emphasize when it comes to Google Research in our work is that we never try to use technology in order to replace the human expertise. We believe that the human expertise and judgment and experience, it's something you can never replace. So we are always looking at the opportunity to take technology and to use it to empower people, to empower the scientist, to empower the teacher, to empower the doctor, to empower the student, and how you can really enhance the human ingenuity using AI, machine learning, and technology, and so on. So these are things that are really special and very important, I would say, part of our values in Google Research. I said that Google Research is covering many topics, many domains. These are the key ones, but it's really only an example, and I will try to share more about what's behind the scenes here. But you see that it starts with the most foundational algorithms and ML. We have people really trying to improve the existing algorithms, trying to bring the new models, the new architectures that I don't know if all of you are familiar with the history, but in fact, LLMs started in Google Research. The transformer, it started with a paper that was written in Google Research. And on the other end of this range, you see the quantum AI. Obviously, Google is a leading company, a leader in this market of new computational technologies and systems. Quantum is obviously the most famous one. And in between, you have a lot of science and society. How to even think about science in our new era of AI and machine learning. We are working with many universities and scientists to help them think about how they can leverage AI. Again, AI cannot really, we believe that AI, at least at this point, cannot run the entire experiment end to end. This AI scientist, we can talk about it later, is only a theory for now, but definitely AI and technology can empower the scientists, and they can help them work faster and spend more time on the areas in the research that really requires a lot of human judgment and human talent. And AI for science includes health and education and so many additional things that I will touch some of them. And what we are going to discuss today, the Earth AI, is somewhere there. It's between science and society, I would say. This is where we are currently going to focus. And more about Google Research, we are spread across the world. We have 1,600 people from Africa, of course, America, Europe, and now, this year, we are opening our first location in Singapore. So we are coming to APAC. We're going to start small, but it's not going to stay small. And our new location in Singapore, we're going to announce it. We're going to officially open it this October. And it's not only Singapore. Singapore is a hub for the area. It's a Singapore for our only beginning of a longer journey we are planning in this area, because we feel there's so much to do there across the board, across everything Google Research is doing. One more thing I want to share about Google Research, and I believe this is the last slide about Google Research before we dive into Earth AI. I want to talk a bit about our philosophy and how we connect between science and innovation and society. And this is something that the head of Google Research, this concept, India, I saw this comment. We already have researchers working from India, so India is definitely there. And also, if you look at the projects we are running, from health to science, definitely a lot in India. India is such a fascinating country, and I have many examples. Maybe I'll touch it later of things we're currently doing in India. And by the way, today we're going to talk about geospatial. Sorry for talking, but this question intrigued me. Today we're talking about Earth AI and geospatial. If there's one country that already announced that geospatial and those geospatial technologies is in their AI policy and AI strategy of the government, is India. And we see a lot of actions and activities in this area in India. We are very, very curious and eager to collaborate and do more there. There was a very big AI summit in India only a few months ago, and we were there. So there's a lot we can talk about India later if you want. But if you look at the slide for just 1 second, I just want to say that, in the past, maybe scientists were sitting in a lab, developing their technologies in this ivory tower, if you'd like, and then they went outside and saw if there's any buyers. This is definitely not our way these days. And we are constantly in a feedback loop between our research, our technology, and the big problems that the society is facing and the big opportunities that we see across the board in many nations, in many countries. And we are constantly trying to connect the dots in order to learn from each other and bring our technologies into applied solutions that will make people's lives better. And this is very, very important. Very, very important. It's not science that is there in a room next to all those computing resources trying to just, publish papers that are very important, super important. We are really in the business of creating science that can change the world and make it a better place. And this is really a great, I think, point for me to move forward and to talk about Earth AI. And I decided to start with a short video, and afterwards we'll share more.
Traditionally, the entire geospatial community was used to the era of putting pictures up in front of their monitor and looking at objects and making sense of what they see. Imagine if you could go from looking at pictures on a display screen to just having insights delivered in a tabular format to hundreds of thousands of customers.
One of the challenges we have in public health is that it's very difficult to get full fine-grained detail about health of populations. With Earth AI, we can actually start to understand which communities are vulnerable and then how to target interventions at those communities.
That's the promise of Earth AI. Time to market has been cut down significantly. So what took years to get to now can potentially be done in months.
What would usually take you weeks of processing, you can really do that in a matter of hours.
That's just game-changing value.
What's really fundamental about Earth AI is that it's for the first time bringing together a whole universe of data sets that allows us to make decisions in a new way.
With Google's Earth AI, you can start to now solve multidimensional problems.
With Earth AI, now we're able to identify exactly communities or villages that are going to be affected by hazards such as floods or droughts.
You can actually see what the forecast level of the river will be in the next couple of days.
Hurricanes will always happen, floods will always happen. The key is understanding beforehand what might happen. It's constant because you get the updates every few hours.
We really can think about a different future and a different world for us. And Earth AI does arm us with the potential to design this future and deliver it.
It changes the game. You have the ability to now work at 10x the speed, 100x the speed. It gives you insights at a scale and at a resolution that we just didn't have before.
And the fact that Google is now bringing this to the world and to businesses to make decisions on and build products on, is just really groundbreaking and extremely exciting.
So after we saw this initial video, and before I even tell you what Earth AI is, I want to start by a question. I want to start by the question of why now? Why are we starting to talk about geospatial now, about Earth AI now, when the technology and the data was there even before? And the answer for why now is really a combination of several different factors. The first one is really the need. We always begin with the need. And if you remember the magic cycle of Google research, this is where we always begin. And you see, first of all, the global challenges around the world with climate and urbanization and people who are struggling to find the data that will help them navigate with very, very difficult problems and challenges. We feel that now when we have the data and technology, there's an urgent need to bring this data, democratize the data, and bring it to the awareness and to the use of people. And also, we always talk about the risks, we always talk about the problems and the challenges. There are also many opportunities. And if you remember, I don't know if everyone knows, Google's mission, Google's vision is to organize the world's data, democratize the data, and bring it to people in order for them to make better decisions and to plan. So this is another example of us not only to take the data from the internet, but also to take the data, the geospatial data, the data about Earth, the intelligence about Earth, and bring it to people and help them seize those opportunities. So this is one reason. Now, besides the need, we also look at the data and we know that we have a very rich databases, very rich data sets about the world. It starts with really an explosion of data, for maps, into satellite images, into data about people and their behavior and the movements. We have all this data. Google has this data, not only Google. And this data really requires some structure, requires some organization, and it's really an opportunity. And I really want to emphasize Google as a key player here because we have this unique signal. we have this opportunity, because where we are positioned, to bring this data and to share it in a way that will be useful. So we talked about the need and we talked about the data. On top of all of this, we cannot ignore the AI opportunity, the AI revolution. Starts with the predictive power. And you know, it's written predictive. I want to add preventive. You know, we can use geospatial and Earth AI in order to prevent unfortunate scenarios and unfortunate events that we can maybe we want to change, we want to avoid. And of course, complex reasoning, the same complex reasoning you see now in Gemini, you can bring it to the planet, and you can come up with very, very challenging questions, very advanced and complicated questions, and get very comprehensive and detailed answers. And I will show some examples soon. So this is why we really are facing a unique point in time, a real opportunity to make a difference in this area of geospatial. Now, I talk about Earth AI so much, it's time for me to present what it even means. And what I like about Earth AI is that I can present everything about Earth AI in one slide. This slide captures everything. If you had to remember only one thing from this entire presentation, this is what you need to know. This is Earth AI. And let me explain what you're seeing in the slide. It begins on the left side. I talked a lot about data, the richness of the data that we have about the planet, especially Google, but not only Google. We have the images from the satellite, and we have radars, and we have a lot of data that we can take from Google Maps, for example, right? You know, we see businesses and the business and the transport, and we have the movement of vehicles, right, through Google Maps and through Waze. And we know people are searching for things, and we know the trends. And we have, Google has the most advanced weather models in the world. There's a lot of data points collected every day. And this is how Earth AI started, in fact. When Google Research people in Google Research were looking at this richness of endless amount of data points, and we said, we can do something with them if we only connect the dots. I see a question about what is business. Business is a layer on top of Google Maps that can show you specific areas. You know, if there are many people there, if it's, I don't know if you saw it in Google Maps sometimes, you can see which areas are, in terms of a heat map, you see which areas are more busy, there are more people there, and obviously it fluctuates over the day, right? It's a activity, exactly, it changes. In sometimes you can go to a restaurant and you see there are more people, there are less people. So this is business. So we have the data on the left side. What are we going to do with all this data? Now we are going to our models layers. You see in the middle, we have three big families of models. One is imagery, and I'm going to, for each of those categories, I'm going to share more in a few minutes. The imagery models is basically our remote sensing, our satellite images, and everything we can do with them. I'm already giving you the bottom line there. What happens when you take images and you connect them with language? And how can you catalog or index those two together and create and train models that can understand what they see? This is the big breakthrough here. And also we have a great technology developed in GDM, developed in Google DeepMind, called Alpha Earth, which is basically a virtual satellite. And I will show you this in a second. So this is images. Now we have another model called population model, or the population dynamics. Soon I will present it to you. We call it the PDFM, Population Dynamics Foundational Model. And here, imagine that you have data that you collect from people, from the people dynamics, from the movement, from mobility, all of this. And here I actually want to emphasize, even before you ask, privacy in everything Google is doing. And of course, here as well is a key concern, is a key priority. So of course, here as well, the wisdom here is not only to do it effectively and in a concise way, but also to do it while making sure that we are securing the data and making sure that we are not looking into the individual, but really anonymizing it in a way that can really allow us to use it. And then on top of all of this, we have the environment models, the weather, the floods, the cyclones, the wildfires. I don't know if you follow, but Google Research is investing a lot these days in all those areas that we call crisis response, climate resilience. There are many names for this. All of these are basically talking about how we can provide preventive intelligence for people to save their lives and to help them navigate with all those changes in the climate. So we have this data on the left side, we have the models in the middle, and then on top of all of this, we have Gemini. And what Gemini allows us to do, by the way, Gemini and also agents, Gemini and agents. What does it help us to do? Many things, but I will give you only one for now. It helps us to let you ask simple questions in natural language, and Gemini and our agents will go through those models and will go through those pieces of data and will give you the answer. I sometimes compare it to Google search, but for the planet. So this vision is very ambitious, but has a huge potential to really make a difference. And this is one of our key projects currently in Google Research. And usually I stop here, but today I want to add one more thing. I often say, this Gemini layer can help you answer questions, but it can do two more things at least. One, it can use a very powerful reasoning agent to not only answer the questions we have data for, but also to use some assumptions and to use some logic in order to show you how we analyze your questions. By the way, everything is transparent and we show you the process. Everything is on your screen and you can see the details. And another thing I want to tell you we can do, and we are only starting doing it, so I cannot share more now, but think about not only about providing you answers, but also predicting what can happen in the future based on the very large amount of data and experience that we accumulate through those models. So we can also start thinking about predictions, and based on early results, it looks promising. So now we can really talk about preventive intelligence about the planet, and the opportunities are endless. So I told you in advance, I warned you that I'm going to spend some time on this slide because I really like this slide. The slide tells the entire story in a one-stop shop.
Shlomi, there's a couple questions in the chat. One you kind of touched on about how frequently the models are validated and how they're validated. And then also one about how does the geospatial reasoning agent differ from a normal LLM?
The biggest difference is that we're talking about a completely different type of data sets. LLMs are based on language. And here in geospatial, not only that a lot of the data is images, so we need to find a way to connect the dots. I said, and I'm going to show you exactly how we're doing it in a second. This is my next topic. But also, it's not only the type of data. It's also, you cannot compare a textual reasoning or video reasoning or images to geospatial reasoning, right? The model needs to understand, or to get closer to understanding. I'm not claiming that we are already there, but our hope, our vision is to model to gradually understand the dynamics on the planet. And when I say dynamics, again, it's complicated. It's the terrain, right? It's the images, it's the how Earth looks, it's the people on the Earth, it's the movement, it's the transportation, it's energy, and it's climate. So there's a lot to accumulate, a lot to integrate, and it's a very, very different type of reasoning, a very, very different type. So as I said earlier, it's an ambitious project. We are not claiming to be where we want to be, but we are really gaining progress. Any other question for now? And I expected this is a very good stopping point for us to collect some questions. Let me move on because I'm looking at the time, and I will leave some more time later for questions. And I promise you will have questions because there's a lot to say here. Let me start by diving into those three categories: the images, the population, and the environment. And I will do it by sharing some examples, sharing some research with you, and even sharing additional videos. Let's start doing it. So remote sensing, as I mentioned, is the first thing I wanted to talk about. The remote sensing foundation, it goes way beyond just pixel matching, because I get this question a lot. We have a pixel level intelligence capable of executing dense downstream tasks effectively. Now, I want to tell you that the data sources we used for this are very rich. We're talking about a massive data set of 300 million high-resolution satellite and aerial images that we paired with text descriptions. This is how those models were trained. The text, the description, the label, the tagging with the image itself. And now we have this vision language models that are based on open vocabulary object detections. And this is exactly the examples you see on your screen right now. It means that those models are capable of semantic and instance segmentations of data, object detections, image classification. You tell them Power Planet, this is what you see. You ask them, show me all the rail crossing in a specific city, and the models can show you this. So those are the basic capabilities here. We think about many use cases that we can definitely take under account when it comes to those elements. Now, let me give you two concrete examples. One on the left, you see the object detection. So here you see in Texas, oil rigs. We just ask the model to find oil rigs up to 10 kilometers, and the model can help find those. And on the right side, this is another function that I want to emphasize. It's called super resolution, or in simple words, based on the trained model, we can improve the resolution and make the images look much more accurate in a high resolution, even if the original data is not as accurate and not as detailed. We're just using the trained models. And here you'll see an example. This is in Japan. Look how the model is able to add additional details beyond what was originally collected, just based on the data that it was trained on. So those are only two examples, and we have many more. Now I want to move to another model we have under this category of images, and this is DeepMind's Alpha Earth. Maybe you've heard about it. What is Alpha Earth? Alpha Earth is basically a virtual satellite. This is the best thing you can do. The best description you can pick up. What exactly are we seeing here? Just imagine lots of information from dozens of different public sources, and they're going into Alpha Earth model, and then accurately and efficiently, they are embedded into a bunch of embeddings. So what it means that each embedding, each piece of embedding captures in it many different angles and many different types of data about a specific area on Earth. Now, I don't know if all of you are familiar with the concept of embeddings. I assume so, but basically those are compact summaries of data connected to a specific location on Earth, and they are very easy to use and can give you a lot of flexibility in terms of the different things you can do with embeddings. And I'm going to show you only a few examples. Before I do, I want to explain, I said that many different types of information, many different layers of data are captured in those embeddings, and I want to give you those examples. This is a list of the things, of the data sources we have in Alpha Earth. And if you notice, some of those, and we are talking about a 64-dimensional data types for each of those embeddings. Now, what's interesting about it is that some of those data sources are what we call traditional layers, right? Those are the maps and the satellite images and so on. But some of those are what we call non-traditional layers, including geocoded Wikipedia text embeddings and biological research, because we really wanted to make sure that those embeddings capture as much data as possible for them to be comparable. And then, as I promised, I said I want to give you some concrete examples, because now I talked about how we created this. Now let's talk about examples. And one of the best examples I always like to give is how you can create a similarity search based on those embeddings. For example, in this description, we took New York City and we asked the model, look around the world and find additional locations that might look like it only based on the data you captured in the embeddings, and look at the results. And you can see there's a key on the side, a similarity based on color. So you see that New York is very similar to San Francisco, to Buenos Aires, to London, and a little bit less to Tokyo, but still there. Imagine the opportunities if you're looking for the next place to build a hospital, the next location for a school. There are many, many use cases that come from this, but not only similarities. There are many additional things we can do with Alpha Earth, from classification. If a government is looking at the status of the agriculture in the country and they want to understand what's the situation based on crops. If you are using regression and you want to, and even if you want to look at change detection, for example, in forest clearing, but this can also be the effects of a hurricane or an earthquake and so on. So basically, everything you want to do, many of the functions currently analysts and geospatial experts are spending a lot of time on, they can do with a basic Alpha Earth. And Alpha Earth is available. If you look at the embeddings are available, they are shared for free with the entire world, and you can use it. So this is really an exciting feature. Before I move to population dynamics, which is the second category of models, I want to stop here and see if there are any questions. Yes, Pete.
Yeah, just got a question about your crop recognition. Say, I teach drones here in TAFE, and we've got a lot of farmers. And can we take our own video and run that through the EAI? Yes. Oh,
so it's a great question, and I want to give you an accurate answer. So
yes,
Alpha Earth is those are embeddings.
Mm-hmm.
So for those embeddings are pre-made, pre-trained, and so the answer is not really. But Earth AI as a whole, our program, is definitely friendly for BYOD.
Yes. Yep.
Your own data. We support it. We understand that this is the current need.
Yep.
I think that when we think today about, and we talk a lot about with people about their use cases, about their problems, we understand that we are not in the world of we give you the data and the users are just, and the agents and the user just comply. Users can create their own agents these days quite easily. Users have their own data. And everything I'm showing you today, all those capabilities are very modular, are very flexible in order to help you to solve your own problems.
Excellent.
So this is the must, it's one of our principles. So I actually appreciate this question because it's spot on.
Thank you.
Are you saying that we can fine-tune on top of Earth AI? Yes, this is what I'm not sure if I fully understand what fine-tune is, but let me share my understanding of this. Earth AI is a set of skills and capabilities and models that should help you solve your problems. We are moving more and more towards this concept of a DIY, do it yourself, and providing you with the skills and the capabilities for you to solve your own problems. That's the only way it can work, because there are so many different use cases and so many different data types and so many problems. We don't believe that we can build a one tool that will solve all of them, and therefore building a customized solution that you can leverage for your own research or for your own product. This is one of the things, this is one of our assumptions, this is one of the things we want to do. How often is Alpha Earth updated? Yeah, I will have to check this with DeepMind to give you the most accurate answer, but definitely it happens quite often, and they are going to share new versions every few months. I believe that this is the current plan, but it changes sometimes, so I can check and I can give you an answer. Yeah, the modularity. By the way, the modularity is something we learn from talking with users, talking with researchers, talking with scientists. we keep learning, and there's no other way because, you know, things are changing so fast and so quickly. We can come up with assumptions, but we really have to validate them all the time. Okay, I have so many things to show you, and we don't have enough time. Let me move forward, because I'm going to show you my favorite model right now, and it's the population dynamics. What exactly is population dynamics? It's our attempt to take not only the globe, not only the Earth, but also people's behaviors and the people's patterns and their the way they move and perform and search for things online. So you see the data sets. We have the search trends and business that we talked about earlier, and maps. And the things we can do with the PDFM, the population dynamics, are very, very broad. From interpolation and extrapolation, super resolution, nowcasting. I'm going to show you some concrete examples. I believe that some of them will surprise you. But before I do, let's dive a little bit deeper into PDFM, and let's see exactly when I talk about PDFM, what does it mean? What can we see here? So we begin with all the data sets that I was mentioning earlier, you know, the business and the maps and the aggregated search trends. We bring it into PDFM. Again, we create a region fingerprints, or in other words, embeddings that are based on specific zip codes. So every embedding is associated with a zip code. And then we continue developing it until we can really create those extrapolations, interpolations that I mentioned earlier, or in other words, we can use it for predictive and preventions. And I want to show you an example. We talked about similarity earlier, and now I want to show you how it works with PDFM. Here you see our agent on the side, and if it's too small, I will read it for you. It says, what zip codes in the US are most similar to Mountain View outside of California? And again, we are using the population dynamics embeddings. And you see that the model, I told you earlier, the model is very transparent. It shows you the way they think, the reasoning process. And after it thinks about it a bit, it showed the results. So again, you can look at similarities using images, satellites, and you can also look at how areas are similar using the PDFM. And above all, if you use the agent and you use Gemini, you can use both. You can use both and create an integrated answer. I see there are questions. I want to move a little bit forward, and then I'll stop for additional questions. I told you that we already used PDFM to do some research, and I want to give you some examples. This is one of examples that I really, really like. Here, this is called predictive behavioral patterns in data scarce regions. What it basically means, we asked the question of how much time people spend at work. And we used multiple models, multiple methods in order to answer this question, including PDFM. So what we did here, we compared models that were relying purely on rich socioeconomic data against models using our PDFM's embeddings. And the results were actually quite surprising and were quite clear. Models that combine the embeddings reduced the prediction uncertainty in a significant way. So here you see how by using the population dynamics models, you can really enhance, improve the predictive power and reduce the uncertainty when it comes to people's behaviors. And I want to remind you, those embeddings are based on searches, on business, but when used in academic research, we see the results. But it's not only about the academy. I also want to show you what we've done in Malawi, because this is very, very exciting. In Malawi, we worked with Cooper Smith, and we were trying to understand the effectiveness of specific efforts the governments invested in when it comes to public health. And we saw significant results in the predictive power in a way that really helped the government to understand where they need to change their policies and when they need to invest more in order to deal with specific healthcare gaps. And this connection between population dynamics models and healthcare is exciting and surprising. And I want to tell you that these days, we are collaborating with the World Health Organization in Africa to address the Ebola pandemic. And we have very, very positive results and very positive outcomes for the research that is being done. It's not only research, because we are implementing and helping the WHO using the PDFM. And it's very, very, very promising. And soon you will hear more about it. So this connection with PDFM and people's patterns, people's behaviors, and healthcare is very promising. And it's a great example how using the data and the models can really make a difference. I want to show you a short video about it, and then I'll collect some more questions.
What's really fundamental about Earth AI is that it's for the first time bringing together a whole universe of data sets that allows us to make decisions in a new way.
Google AI is helping us drive better public health insights, which will ultimately drive better decisions. We can start to actually fill in the gaps, places that may not have solid data, or places where we want to see what future risk might look like.
With Earth AI, and generally what we're seeing with the explosion of data sets, is you can start to now solve multidimensional problems. How extreme weather events affects housing affordability, how housing affordability affects transportation demand, how transportation demand affects traffic operations. Working with Google Research and Earth AI allows us to think about the art of the possible. Sky's the limit.
My name is Stefan Pretorius. I'm the Global Chief Technology Officer for WPP. WPP is in the business of building brands and then connecting those brands to consumers. Brands have to connect to consumers in the world where they are. And Earth AI, and particularly the Population Dynamics Foundation model, gives us that data for the first time in a way that is easy to consume across all our products.
My name is Anand Dinamani. I lead Deloitte's transportation practice here in the US. If you think about transportation at large, it has been mostly an engineering problem. So instead of continuing to build new roads, can we use them better? Earth AI brings tremendous amount of insights and geospatial data together that has lacked in the industry. You're able to combine the power of Google Cloud with Google AI, with Earth AI, and then eventually the Maps and Waze platforms.
The first time that we saw PDFM, Population Dynamics Foundation model, we were immediately excited about the potential for connecting real-world physical data to our marketing data sets. We have a large marketing model in WPP that we call Open Intelligence. It's really an aggregation of lots and lots of different marketing data sets, and we've already integrated PDFM into Open Intelligence. What that allows us now to do is to connect everything that we know about how consumers buy, how they perceive brands, how brands are competitive with each other, and connect that with things like, for instance, traffic data, weather data.
Deloitte's Infrastructure Insights Pro platform is really a geospatial AI platform. Everything is geographically centered. Where the roads are built, how they're built, where people live, how they commute. When we combine the power of Infrastructure Insights Pro platform with Earth AI, it brings together not only the power of Earth AI, but the ability of a fully cohesive platform upon which you can now deploy all the client data sets. When you bring all this data together and with the power of generative AI, just like we do with Gemini, you can talk to your data. That's just game-changing value.
My name is John Brownstein. I am the Chief Innovation Officer at Boston Children's Hospital and a professor at Harvard Medical School. Right now, in a world where we have very limited data about the health of populations, with Earth AI, we can actually start to understand which communities are vulnerable and then how to target interventions at those communities to increase vaccination rates or to message people about the risk of these pathogens. We've processed these models, we've built these risk maps, and of course, we want to validate them. We have seen outbreaks of measles happen over the past year, and the model predicted exactly where those outbreaks were taking place. So we know that these are valid models that help us forecast where we should expect risk in the future. In a world where vaccine uptake is reducing, we want to be ahead of the curve. Earth AI is giving us a whole new set of data that we just didn't have access to before. We hope this now extends into the public health community so organizations, local public health, state, and even CDC can leverage these tools.
The ultimate goal here is to democratize access to trustworthy information at every levels of the government, down to the communities.
I think that AI is really transformational for the marketing industry. It moves us from a digital-only view of the consumer to a consumer that lives in the physical world and everything that impacts that.
Now with these models, we have a completely game-changing set of tools that we can use to actually protect communities.
Earth AI does arm us with the potential to design this future and deliver it.
I wanted to take a few questions now, if there are any. I saw a question about PDFM and data commons. We're working very closely with data commons. PDFM is not part of data commons, but we have several projects in which we try to combine those. For example, can we imagine a virtual census that can save a lot of time and money for governments when they want to map their populations? This is one example of things we can do together with data commons, and there are more. What are the ways we can access you didn't miss? I save it for the last slide because I want you to stay till the end. So this is why I don't share it now. Any additional questions? I want to, what is the resolution of satellite images? All the technical questions like this and resolutions, I'm not going to get into it now. But first of all, I'll show you we have a beautiful website. Even there, I don't think you'll see the resolution, but once you fill out our interest form and we talk, I think the data will share it with you. Also, it changes sometimes. It depends. I don't want to get into that. Okay, there are a few things I still want to show you. So let me jump into the next topic, which is mobility AI. Mobility AI, just to complete this topic of population dynamics, because population, it's not only people, it's also how people are moving from one place to another, and of course with vehicles. I want to give you two examples. It wasn't easy for me to choose, but one is traffic safety. In traffic safety, I specifically want to show you, maybe it's too small, but I can show those videos afterwards. We basically used our models to look at where people are stepping on the brakes at the last moment. And we use this data in order to identify the specific locations, the specific conjunctions, the specific conjunctures, the specific areas that are maybe dangerous, because we see recurring last-minute breaks in those areas. And we provide this data to cities and governments in order for them to make decisions about how they can improve the safety of the infrastructure, the transportation infrastructure. And in the other example, again, part of the mobility AI, we are actually taking all the data that we've collected, and we help cities and governments to assume some scenarios, or to assume some new futuristic circumstances, and see how those new assumptions, new configurations can affect the transportation. And it helps a lot to plan and to think and imagine new infrastructure options and infrastructure visions. Those are just two examples of things we do, and you see that the connection between the data and the action is very, very close. We are really trying to make Earth AI as effective, as actionable as possible. Moving forward, I want to talk a little bit about weather, not too much, but I promised you that we have three layers. You remember, we have the planet, we have the satellite images and the imagery, we have the population, including mobility, and now weather. Google is leading in every table, in every ranking. You will see Google models for weather are number one, or really the top in terms of the forecasting, including cyclones, including floods. In fact, if you look at the news, in the last incidents of cyclones and storms, Google was, I think, the only model that was able to give people a heads up, an early warning that the cyclones are coming, and we also can predict the route and so on. And floods, we have more than 2 billion people around the world that already get early warnings about floods. This is a personal project, I would say, even of the head of Google Research. And also we have wildfires. This is not here. Now imagine that all of this data, we see all of this as part of Earth AI, and we're trying to combine all of this into one place. So imagine this, and this is one of my favorite examples. Imagine that you bring all of this together and you ask the agent, where a storm is approaching the shore, where is the storm going to hit? But not only where, not only predict the route, but also how many hospitals or schools are in danger because of this. So first the model will calculate where the storm is heading, but then it will take all the data about the hospitals and the schools, and then it will give you a comprehensive answer that takes the population dynamics, the image satellites, the weather. It will just integrate all of this, and you asked a very basic question in a simple natural language using this Gemini chatbot. But we are connecting the dots. This is the real power of Earth AI, in this case in crisis response, but of course there are many, many different scenarios we can think about. I have another video, but I am looking at the time, so I'm deciding to skip this one now, even though it's super interesting, because I also want to leave some more time for questions. I would tell you that all the videos I shared with you today can be found online in YouTube, in Google Research channel in YouTube. Type in YouTube Earth AI, and you'll be able to watch those videos, present them to others, share them with others. So it's not only in this slide. I'm approaching towards the conclusion, the end of my presentation today. Who could have believed that 1 hour will move and will pass fast, so fast? When we started working on Earth AI, and you see it's at least 2 or 3 years that we are working on this, it took a lot of time. There's so much work captured in those simple slides and simple videos with hundreds of different models that got better and better over time. Eventually, now we are focusing on 3 specific populations. We are looking at businesses, enterprises, how we can help them reinvent themselves. We're looking at consumers. We are not there yet, but we are definitely thinking about how we can bring this promise of Earth AI into Google's applications and Google consumers' services, and maybe also help consumers and users around the world to use more of this technology. But we are also looking at the society and how we can work with governments and cities and non-for-profit organizations. And we are, in fact, these days are collaborating with Google's philanthropic arm, google.org, in order to fund many of those organizations that are going to apply and ask for us to help them. And it's going to, I hope, move the needle in some areas. Now it's the time where I tell you where you can find all this data online. So, and you have those QR codes. You have our website. Our website is brand new. It's only a few months old. And you see the address here as well. You are more than welcome to visit. You can also Google Earth AI online, and you'll find everything you want about Earth AI, including the videos, including data, including the different models that we have. You have the technical report that we published a few months ago with all of the information that and all the evals and all the validations that we did to Earth AI to make sure that indeed it's based on science and scientific outcomes. And eventually, you have the interest form, and we are tracking this interest form. If you have an interesting use case, if you want to collaborate, if you want to partner with us, please use this QR code, and we can talk to you and see what we can do together. Lastly, and I know we have 4 minutes, and I want to leave time for questions, just one more thing I want to tell you about. It's a very exciting opportunity. We have the AI for the Planet Accelerator led by GDM in Singapore in the next few months, but the deadline to apply, as you see the key dates, is July 26th. Based on my calendar, this is in 2 days or something like this, 3 days. The reason why I even present it, first of all, because I believe that this is a very exciting opportunity, but also because Earth AI is going to be part of it. We are collaborating with GDM. We are going to bring some of our models to this accelerator and to work with the people who are going to participate in this accelerator and to show them what we're doing in Earth AI. So again, a great opportunity for you. Don't miss it. Now we have some time for questions. April.
You're muted, April.
Hello, sir.
Yes.
Can I have a doubt?
Yeah, April, let's talk with Rex.
Oh, here we go.
Oh,
Go
April,
ahead.
sorry. April, go ahead.
First off, thank you for having me. I'm so excited to be a part of Earth AI. I'm collaborating with a governor in the next 2 weeks on infrastructure. So I'm really, really excited to start to use this program and see what I can come up with. So thank you again for having me here.
Thank you so much, April. We appreciate this, and it's great to have you here. Rex, you're next.
Yes, sir. Sir, I'm actually from India and I'm a 19-year-old student. And I have a doubt that I actually working on the same project which you said. Like in real time, if we upload the image from satellite, we can actually predict the crop type and its growth stage. And using our own trained model, we can predict and say how much water is necessary to irrigate the crops and everything that's there. So actually, what would you suggest me that which type of ML model would be best to train the crops?
First of all, sounds like a great use case, and agriculture is for sure a very, very interesting domain we are looking at in Earth AI. The short answer is that please reach out to us. Please use the interest form, and we can have a proper conversation over email or over chat to give you all the details. I don't want to give you, a simple answer without really digging deeper into your use case. But really, this interest form is exactly for this kind of questions. And thank you for joining today from India. Asmet, you're next.
Thank you, sir.
Thank you. Asmet.
Hey Shlomi, thanks for this insightful video. I just wanted to quickly check on the accelerator part. Is that something which is, because I do have an idea, I'm working on a prototype. So is it something only meant for startups, or is it someone who has an idea and has a prototype? And I mean, who is it for? So the accelerator thing.
I really appreciate this question, and thank you for this. Yes, all of you, reach out to us. We are looking for interesting opportunities, and social impact is super relevant for startups. And maybe you have an idea that we haven't thought about, and together with you, we can partner and we can change the world. Reach out to us, and we'll be happy to discuss. Yes,
sure.
Relevant for.
So I'll check out the accelerator then. I just thought it's only for the enterprises and the startups. So
No. It's for anyone who can. We believe that Earth AI can be leveraged to make the world a better place. Yeah.
So should I only apply for that, or should I also fill out the interest form? Like how does it work?
Reach out to us through the interest form. Let's talk.
Applied for everything. Yep. Shlomi, we're going to have to wrap that up. Thank you so much. And if you have more questions, feel free to send them through, and maybe we can answer them offline. But once again, thank you, Shlomi, and hopefully to see everyone soon. And see you next time. Bye.
Thank you. Goodbye.